Okay, so we've talked about inverse cosine before, and we've used that now to solve backwards and law of cosines to find missing angles of side-side-side triangles, and today we're going to start looking at the inverse sine and tangent functions. So a question we might be thinking about is if we were given a right triangle like this one, how would we find the angle theta below? So if we look at the right triangle that we have, we know that this side opposite the right angle is the hypotenuse. And we know that the side opposite the angle is where the 4 is. So since we would have opposite and hypotenuse, we know that this ratio is true. So we know that sine of theta is equal to 4 over 5. And we're interested in knowing what the angle is. So we have to find a way to get the theta outside of the sine function that it's trapped in between. Because even though we don't always write it, there's technically parentheses around this angle value that are trapping the angle inside of the sine function, and we want to get the angle out of there. So we're going to talk about how to do that. So just like with the cosine function, we have to restrict the domain of inverse sine and tangent. So we have to only look at a specific section of values. So again, when we restrict the domain, we want it to be continuous values. We want to show all possible values, so all positive and negative values. And we want to include the first quadrant. So if we're looking at the unit circle, so instead of looking at the graphs of sine and tangent, we're just going to look at the unit circle. So we know that we want to include the first quadrant. So we're going to definitely shade over all of this region. So we're going to include this in both of our domains for sine and tangent, yep. And then we also want to consider the fact that all of our functions are positive in the first quadrant. So sine is positive in the first quadrant, and so is tangent. So I'm just going to go around the circle and label. So we know in the second quadrant, sine is also positive, and then in the third and fourth quadrant, sine is negative. Well, tangent is really equal to sine over cosine. So in the second quadrant, since cosine is negative, tangent is also going to be negative. In the third quadrant, both sine and cosine are negative, so tangent is positive. And in the fourth quadrant, it goes back to negative since sine is negative, but cosine stays positive. So we want to include another quadrant of our circle that touches the first quadrant, that is continuous, so that it's continuous, and that we want to show the negative values as well. So for both of these functions, that means we have to include the fourth quadrant. So now to write that as a continuous domain, we wouldn't want to say 3 pi over 2 to pi over 2 because 3 pi over 2 is bigger than pi over 2, so you can't say that that way. So in order to go backwards, we label this as negative pi over 2. So remember, we start up here at 0 at the x-axis, and when we go up, it's a positive direction. So when we go counterclockwise positive, clockwise it's negative. So when we go down like this, instead of just counting forwards with the positives, like we have pi over 6 here, and then pi over 4, pi over 3, and then pi over 2, we just count the same way backwards. So this is negative pi over 6, negative pi over 4, negative pi over 3. So our domain for both of these functions, we write it as negative pi over 2 is less than or equal to theta, which is less than or equal to pi over 2. So when you use the inverse sine and inverse cosine functions, your answers are going to come out between those two numbers. So here are our formal definitions of inverse sine and inverse tangent. So in the first one, y is equal to sine inverse of x if and only if x is equal to sine of y and y is between negative pi over 2 and pi over 2. So remember, the sine inverse gives us the angle. So if we were to write it out in words, we would say an angle is equal to the sine of a number. And the angle has to be between negative pi over 2 and positive pi over 2. So we're going to cover the first quadrant of the circle and the fourth quadrant of the circle. So we're going to cover the right-hand side. So we're just looking at that. And then same thing for tangent. Y is equal to tan inverse of x if and only if x is equal to tangent of y and negative pi over 2 is less than y, which is less than pi over 2. So here we don't include the two endpoints. because the tangent function is undefined at pi over 2 and negative pi over 2, so we don't include them in our range of the inverse tangent function. So again, we have that some angle is equal to the tangent inverse of a ratio or a number, and that the angle has to be between pi over 2 and negative pi over 2, but doesn't include the endpoints. So let's go ahead and start using this, that way you guys can see how it works. So in our first example, we're first going to evaluate sine inverse in radians of negative 3 pi over 2. I don't know why it says in radians twice. Okay, so if we look for that, sine is negative, so if the sine ratio is negative, that points us to fourth quadrant for our sine inverse function. So I'm going to look at my fourth quadrant on the unit circle, and remember, we're only looking from pi over 2 around to negative pi over 2, which means I'm not even going to look at the second half of the circle, so I'm just going to black it out. Okay, so I'm looking for negative root 3 over 2, so negative root 3 over 2 for sine, that's the y coordinate, is right down here. So on my circle it says 5 pi over 3, but I know that this is really negative pi over 2. This is positive pi over 2. So if I'm going backwards from the x-axis, I need to count by negatives. So instead of writing my answer as 5 pi over 3, I would write negative pi over 3. So my final answer here, so sine inverse of negative root 3 over 2 is equal to negative pi over 3. Okay, let's do the same thing for tangent. So here we want to evaluate tan inverse of negative 1 in radians. Again, since tangent is negative, that points us to a fourth quadrant answer for our inverse tangent function, so for the angle. So remember, tangent is sine over cosine. So if tangent is equal to negative 1, that means sine and cosine are the same numbers, except one of them is negative and one of them is positive. So that points me to this angle right here, where I have cosine is root 2 over 2 and sine is negative root 2 over 2. And just like the last one, we're not going to write our answer as 7 pi over 4. We're going to have to write it as negative pi over 4 to stay inside that range of the inverse tangent function. So we're going to write tan inverse of negative 1 equals negative pi over 4. Okay, so just like with cosine, we don't always only use unit circle values for inverse sine and inverse tangent. So we're going to go to our calculators now. So just like the other ones, to get your calculator keys to pop up, you always press the second key and then the trig value that you want. And so we always want to make sure that before we start typing anything to our calculators, we go and check the mode of our calculators. So we want to suppose that theta is an angle in a triangle and the sine of theta is 0.7214. And we want to find theta in degrees. So I'm going to go check my mode. I'm already in degree mode, so I'm good to go. So I'm going to hit second sine and then type in 0.7214 and hit enter. And I get that if the sine of theta is this, that means I want to know what theta is, so that tells me to do the sine inverse of the sine ratio number. And that's going to tell me, if I use my calculator keys by pressing second sine and using the sine inverse function on my calculator, that is approximately 46.17 degrees. Okay, we're going to do the same thing for arctan. So just like we talked about arccosine, arctan and arcsine is just another way of writing tan inverse with a negative 1 exponent. So again, we're in degree mode, so I'm going to go ahead and type second tan inverse into my calculator, type in 4 and my parentheses and hit enter, and I'm going to get that that is approximately 75.96 degrees. Now, if we look at the top, there's technically more answers to that question than just the 46.17 degrees, but we're going to get into that in class. We're not going to worry about it right now. We're just going to worry about the basics. Okay, so this is a great example to look at. We want to explain why sine inverse of sine of 5 pi over 4 is not equal to 5 pi over 4. So if we look at the two functions, we have sine inverse and sine. So normally when two inverse functions are directly next to each other and touching each other, they cancel each other out and we should just get whatever is left on the inside. So in theory, we should just get 5 pi over 4. But we're going to go through and work this out. So remember, when you're working through compositions of functions, you always start with the inside. So we're going to start by evaluating sine of 5 pi over 4. Well, sine of 5 pi over 4, that's in the third quadrant, so sine is going to be negative. So, and since it's a pi over 4, that tells me it's root 2 over 2, and third quadrant negative. So my sine of 5 pi over 4 is negative root 2 over 2. So I'm just going to go ahead and draw a circle real fast so that we can use it as a reference point. Okay, so when we're continue to evaluate, we now plug this answer in for the whole function of sine of 5 pi over 4. So we now are evaluating sine inverse of negative root 2 over 2. So remember, the sine inverse function only covers the first quadrant and the fourth quadrant of the circle. It goes around from negative pi over 2 to positive pi over 2. Well, if we look at negative root 2 over 2, that tells me my angle should be about here because sine is negative, so it tells me it's in the fourth quadrant, and negative root 2 over 2, that tells me that this is negative pi over 4 here. So this final answer is negative pi over 4, which is not the same thing as 5 pi over 4. And we would say that if we wanted to fully write out our answer, we would say sine inverse of sine of 5 pi over 4 does not equal 5 pi over 4 because 5 pi over 4 is not in the range of the sine inverse function. So we can't actually get that out of a sine inverse function as an answer. And of course, we wouldn't be talking about math if we weren't talking about applications, because math is everywhere. So we're going to talk about one application of inverse tangent. There's many applications for both inverse tangent and inverse sine. We're just going to look at this one though. So we have a plane is flying at an altitude, which is the fancy word for height, of 32,000 feet, which is about 6 miles, and wants to descend to an airport runway X miles away at a constant angle theta. So let's draw a picture of what's happening. So I am not going to embarrass myself by trying to draw an airplane because my airplanes always look like whales. So I'm just going to say, here's my airplane. Try that again. We have an airplane over here. So here's my airplane, and here's my airport. So my airport is on the ground level, so I'll give myself some grass down there on the ground, and then I want my plane to fly in. So this is my flight path right here, the black line. So this is how the plane is going to get to the airport. And they told us that the airplane was flying at a height of about 6 miles or 32,000 feet, and 6 sounds like a way better number to write than 32,000, so I'm going to use that. And then we know that we are X miles away from the airport. So I'm actually even going to draw it as a rectangle so I can show you that there's two different triangles. So we have 6 miles over here and X miles up top. Now we want to descend at a constant angle of theta. So because we are descending, we want to look from the viewpoint of the airplane. So if I'm up here on the airplane, if I'm descending, I'm creating this angle right here. So I'm going to put my theta here. You could, if you look at it in the bottom triangle, you are also looking for the angle that you would be elevated from the airport. So those are the two places you could put your theta value. So you can look at it in the two different triangles, the lower triangle or the dotted upper triangle. So we want to write an equation for theta as a function of x. So looking at what we have first, we know that opposite of theta is the 6, and adjacent to the theta is the x. So that tells me I have tangent. So for part A, we know that the tangent of theta is equal to opposite over adjacent, so 6 over x. But now I want a function of theta. I want to write an equation for theta as a function of x, which means I need theta by itself. So to get theta by itself, I need to get this tangent away from it. So I need to move it to the other side, and when I do that, I get inverse tangent. So theta is going to be equal to inverse tangent of 6 over x. So that's part 1. Part A, I guess. And then part B, if x is 30, find theta to the nearest degree. So we're going to take our formula and we're going to plug in 30. So we have tan inverse of 6 over 30. Well, 6 over 30, you can reduce it if you want, or you can just type this straight into your calculator. I'm going to reduce it. So that's tan inverse of 1 over 5. I'm going to go to my calculator, make sure I'm in degree mode again. I am. So I'm going to go type second tangent to get my tan inverse function. Type in 1 divided by 5, close my parentheses. After I'd hit enter, I get theta is approximately 11.31 degrees. So for this problem, they ask it for the nearest degree. So nearest degree would be 11 degrees. And that would be my angle of descent of the airplane. Okay, so now that you've finished taking notes on sine inverse and sine of tangent, let's try that again. Inverse sine, inverse tangent. And again, those are sections 5.4 and 5.6 in your textbook, I believe. I want you to complete numbers not 1 to 21. I had a little bit of a dyslexic moment, apparently. We're going to do 1 to 12 from the inverse trig functions worksheet. So that should be attached to your note sheet right now.